path of the particle is shown below. This particle moves so that its position vector is given by r of t, which is this column vector here, where t is the number of seconds the particle has been in motion. Determine the starting position of the particle and mark this as point A on the diagram above. Well, r of 0 will be -2 cos 0 over 1 take away sine 0. Cosine of 0 is 1, so that is -2. Sine of 0 is 0, so this is -2, 1. So -2, 1 would be just here. Determine the initial velocity of the particle and illustrate this on the diagram above. So let's differentiate to find the velocity. Now, cos differentiates to negative sine, and with this negative, that is going to end up being positive. So we've got sine t over 2 multiplied by a half, so that will cancel the 2. So it's just going to be sine t over 2. Sine differentiates to cos, so that's going to be negative cos t. And so v of 0 is going to be 0, -1. So that's directly downwards like that. So that is the initial velocity. Or at least it's on A, but you get the idea. It means the particle's moving that way. Actually, just thinking about how to represent that, I might actually do that and write 0, -1 next to it. We could actually make use of the scale, because that's 1 from there to the axis. So I could do that would be better. Okay, where do we go to next? Write the expression in terms of trigonometric functions for the distance of the particle would travel in completing one circuit of the given path. We know that that's going to be to do with the modulus of the velocity. So, what's going to be the period? For the y component, because of the sign here, it's just 2 pi. But because of the t over 2 here, it's going to be 4 pi. So to completely go around the circuit, it's going to be 4 pi. So we're going to have the integral from 0 to 4 pi of the square root of sine squared t over 2 plus cos t, doesn't matter about the negative because we're going to square, cos squared t dt. I realise I just wrote that off the bottom of the screen. So 0 to 4 pi sine squared t over 2 plus cos squared t over 2 square rooted. So that's going to give us the modulus of the velocity. Okay, so do not evaluate the expression. I suspect that if you put that in your calculator, it will whir away for a little while. So just follow what they're saying there. Now we want, in the last part there, it said determine the Cartesian equation. So we've got x is equal to -2 cos t over 2. And y is 1 minus sine t. Okay, so what we've got to do is eliminate t. Now I might make use of cos 2a is 2 cos squared a take 1, which means cos of t would be 2 cos squared t over 2 take 1. So x squared is 4 cos squared t over 2. So x squared would be twice. So cos squared t over 2, 2 cos squared t over 2 would be cos t plus 1. So cos t plus 1. And so x squared is going to be 2 cos t plus 2, which gives me that cos t is equal to x squared minus 2 divided by 2. Now, sin t is equal to 1 minus y. So sin squared t be 1 minus y all squared. Sin squared plus cos squared is equal to 1. So 1 minus y all squared plus x squared minus 2 squared divided by 4 is equal to 1. And there are many alternative forms that you could write that in, but I'm just going to leave it there.